All right, should be live now. Good afternoon, those that have joined. We're going to give everybody a couple minutes to join, and then we'll get started here momentarily. We'll give it a minute or two. Give everybody one more minute, or not even quite.
All right.
Then we'll get started.
Go ahead and start sharing here. Oh, maybe. There we go.
Very good. All right, well, we're going to go ahead and get started now. Welcome to our talk today. We're going to talk around how to continuously optimize modern cloud-native platforms. Go ahead to the next screen. We'll do quick introductions. Hopefully, you had a chance to see our faces there right before we got started. But I'll introduce myself and then let everybody introduce themselves. My name is Terry Brennan, Managing Director at ORC Software. And in particular, focus on our services group, which help people in their DevOps and cloud journeys and help them hopefully drive success and change their organizations to maximize their investments in those spaces. So I'm glad to talk with you today. Adam, you want to introduce yourself?
Yeah, absolutely. Thanks, Terry. Adam Yaz. I am the product specialist for CCM here at Cloud Cost Management at Harness, responsible for our global go-to-market on cloud cost management. Robin?
And Robin Elliott. Nice to meet everyone. I'm a sales engineer. I support Adam and some of his colleagues technically here at Harness.
Very good. All right. So thanks for joining us. We're going to go through in a couple different pieces. I'll run through and sort of talk a little bit about ORC and sort of our DevOps and cloud cost, cloud overall and cost services that we provide. We'll go through and look at Harness CCM and Adam will do some introductions there, and then we'll jump into the demo and talk about making some of this stuff real and how that works. And then there'll be some time for an open Q&A at the end, hopefully, and we'll take questions as we can. So go ahead. All right. So as I mentioned, my name is Terry Brennan. I'm with ORC. So we are a company that helps our customers in a lot of ways, but on the services side, we certainly help them optimize and implement or build strategies around their cloud and DevOps focus and investment. Go ahead and go to the next slide, please. So we help our clients in their journey and both on the cloud and DevOps side. And we like to say we meet you where you're at. That may be that you're just starting. So it's helping you assess your current state and to develop your future state and strategy and roadmap for how to move forward. We can help you sort of recalculate or figure out how to move across that within the journey. As we get down through there and we've done the roadmap and move those things forward, we both coming out of those will help our clients from a delivery standpoint, implementation standpoint, or oftentimes we come directly in to help from implementing different pieces of the DevOps change and transformation, whether that's in the continuous integration space, the continuous testing space, the continuous deployment and delivery or data or any of the areas around that. And then we can also help from a managed services. And we help across the life cycle from when you come in. So, how does this connect from a development and agile and planning standpoint? How does it move through the whole pipeline from, how you manage the code, your SEMs, how you do your builds and configurations and infrastructure as code and test automation and deployment automation, and whether that's at a dev level, QA, UAT stage, onto prod, production deployments, rollbacks, monitoring, literally across that life cycle and spectrum. So go ahead and go to the next slide, please. And what we do is we help our clients hopefully move to more of a continuous flow, leveraging some of the ideas and concepts from Lean. The ones you hear about often, CI and CD sort of in the middle, that's bread and butter and things we help our clients do. But we also bring some ideas and thought leadership in some of the other areas that may be focused on certain areas and how they integrate in, whether that's the continuous compute and continuous cloud, continuous data testing, visibility, even up to the top on some of the overseeing sides, and then what feeds it from continuous planning and innovation, as well as the running side. So how do you, if you have to go to an ongoing group and ongoing operations, how do you build all that in a continuous manner and build feedback into that? Go ahead and go to the next slide. And we do, as I mentioned earlier, we do that from end to end in the IT value stream, really looking at each of those, how they connect, where there's blockers or waste that we can help the client eliminate, or we look across that overall cycle. Go ahead and go to the next one. And we do that not just on the technology side, which I think people think of with DevOps, but we do it across people, process, technology, as well as culture. Because we find, even if it's a focused area like continuous testing versus all of DevOps, it's still a pretty significant cultural shift in having new processes, new ways people are interacting and working together, new tools and technologies that need to be utilized and deployed. So we look really across not just the technology, but people, process, and culture as well. Go to the next one. And we do that to create DevOps capabilities that hopefully allow us to hit all of these. And sometimes we're taking, if you will, maturity steps along it, but fast, predictable, continuous with quality. So we're looking across that life cycle and that pipeline, looking at the different areas, how we connect the tools, how we automate and build more efficient capabilities, drive a lot of this to cloud, and then manage that cloud effectively, leveraging things like ephemeral environments and whatnot to really change how software can be delivered and to do that in the best way possible. Go to the next one, please. And then finally, bringing those continuous flow capabilities to the pipeline, to our compute and cloud, to our test, and to our data, so that we're now connecting all of those and doing this in a very efficient and optimized for both from a cost and resource efficiency. Go ahead to the next one. And we do that across our DevOps and our cloud side. On the cloud side, bringing that to overall governance, so cloud governance, cost, operations, and automation, and setting up really cloud services, which are, yes, if you will, the cloud architecture and that side of the equation, but also the rest of the supporting capabilities that are necessary to run an effective cloud program, both from a cost, but also from an operating and overall delivery perspective. And one more slide, two more slides, to improve, speed, cost, and overall capability, and driving to client success, where, we've worked with clients to bring them to a fully cloud-based solution, but also to automate that pipeline and to be able to do things like, reduce times by significant amounts, sometimes multiple people over 8 to 10 days for a single cycle, and moving that down to be able to run those in parallel, because we're using cloud-based and ephemeral environments for multiple use cases, and do that in a matter of a 1 to 2 hour total cycle time. So that's sort of how we help our clients from both the DevOps and a cloud optimization standpoint, and helping them move their businesses forward. All right, thank you.
All right, thanks, Terry. Okay, so to dive into that a little on the harness side, so we're partnered up with Oracy as a DevOps platform. Cloud cost management is one of the solutions that we've got as part of the overall harness platform. So we do things that you can see all the way across the bottom there, from CI/CD to feature flags to CCM to security test orchestration to chaos engineering and so on. So come on, advance. There we go. 3 big areas within cloud cost management that people are really trying to address today. First and foremost, there's the transparency side. So this is, really the origin of CCM tools, was the way to pull that data out of a cloud provider, whether that be any of the big 3s or others, and drive reporting. Hey, this is how much data or how many resources we're using. This is how much we're spending. This is how we're pulling everything into different business units. They took a lot of that and built optimization on top of it, which is really, again, a reporting solution of saying, hey, these are how well your resources are running or not, and these are some changes you should do to make that more efficient. And most recently, people are getting into the governance side of like, hey, your resources should be tagged. This is where your budgets are. This is how much you're spending and how much you're allowed to spend. So what we did is we took a lot of the stuff that you have to have, right? The reporting, the dashboarding, and then we combined that with that optimization side of this is how we should resize resources, and then, which is more of kind of a passive thing of cloud cost management. And then added in a function that we call auto stopping, which is more on the active side of cost management and controlling what people are doing and how resources are running. So we've built a tool that really, really nicely brings together finance with engineering and helps them work together to drive a more efficient and more well-controlled cloud infrastructure. So the 3 big things that make Harness unique. First and foremost is, of course, the BI and dashboarding functionality is actually an OEM of Google's Looker. So it gives you the ability to really easily slice and dice data and apply different metrics within your business to them, whether that be a specific business unit or even simple things like tags and accounts out in the cloud. We can roll these up and create things that are meaningful to people. A big hole that we saw in the market was really around Kubernetes cost management. So historically, tools have looked more on the infrastructure side of VMs or databases and that kind of stuff, and haven't gone deeply into Kubernetes. So this is something that we invested a lot of time and resources in, both looking at the clusters there and showing how many resources were provisioned and how well they're being used. So we can identify, idle costs and idle resources that were provisioned as part of a workload, or we can look at things that are just maybe even an oversized cluster showing, hey, this cluster itself is provisioned too large and is a candidate for resizing. We can take that level of metrics and data all the way down to the pod or workload level and say, hey, we've got all of these individual pods running a deployment and an application within Kubernetes. This is how much it costs for that individual pod to run. So that ties right back into the dashboarding side and being able to allocate that back. And it also, this is how well it's running and how many resources it's using. Here are candidates for reconfiguring. Now, the final thing is where this gets really, really interesting. We're seeing a lot of customer interest within Harness, and this is our intelligent auto stopping. Now, what auto stopping does is it takes a look at VMs, containers, databases, any sort of cloud-based resources that are running in a pre-production environment. And when those things are running, they're costing you money. So what we can do is we can look at them and determine whether or not people are using them. We can look at them from a resources standpoint. We can even look at them at an application level, especially on like a web-based application. And when people aren't using them, we can shut them down and then bring them back up when people need to use them. So we can do this without any sort of manual switch on, switch off labor. And then what that does is that also gives us the ability to run pre-production environments on spot instances. So you'll see, 70 to 90% savings running your pre-production on spot, plus the additional savings that we get by not running those workloads for pre-production when they don't need to be used. So talk a little bit about a customer that joined us at the end of last year. These guys were actually a competitive takeout of a different tool. Some of the areas where they were struggling is really around the reporting side. What are our anomalies? It would take them a month or two to go resolve anomalies, and that was a significant amount of money. One of the things that we did as part of a proof of value for them was to create a report that showed how much unallocated cost there was within their largest Kubernetes clusters. So Robin on the phone actually built that report. And what it did is it showed each cluster that was wasting more than $4,000 a year. So that one report, we were able to find about a little over $1 million worth of savings there. And then we implemented auto stopping there and found another about $1 to $1.25 million of the savings there, being able to shut that down. So netted out, this customer saw about a 60-day ROI by implementing Harness Cloud Cost Management. Okay, so now I think we'll switch over to the demo for Robin. Let me stop sharing here.
Thank you, Adam.
Absolutely.
Hopefully everyone can see my screen. So I'm going to take you through the system a little bit. I'm going to break it down into a couple of sort of core areas. The first one we're going to tackle is visibility. Then we're going to get into some specific capabilities that Harness has. I mean, we actually started as a CD, continuous delivery company. And then the next thing we immediately got into was the management of cost around what you're actually deploying to. And so we've got a sort of heavy focus on containerization, be it Kubernetes, ECS, etc. And then I'm going to talk a little bit about automation. So it's one thing telling people, hey, you've got stuff sized incorrectly, but how do you actually make them, help them achieve those savings via automation? So real quick, we're on the overview screen here. A couple of things to point out. We're agnostic to the cloud vendor. We support all three major players. I think I saw a report just yesterday where they've all increased their market share, so they now own somewhere just below 70% of the market. Just a high level, we can see certain things around cluster breakdown, cost by provider, etc. But let's get into some of that more deeper visibility with perspectives. So whilst I can view a perspective from my cluster spend or specific cloud vendor spends, obviously perspective is where I want to encapsulate a cost that someone either owns or they care about. Yeah. So in this example here, I've got a perspective for an application, the web order platform. And I've been able to define all the cost components across multiple clouds that make up the cost for this application. We can see in the header area, I've got my total cost, the trend. I can set up budgets. I'll go into those in a little bit more detail in a minute, but we've actually got monthly and quarterly budgets set up for this. It's forecasting where my spend's going. And I've got some recommendations as far as resizing some of my containerized application. Down below, I can actually slice and dice this data. Currently, I'm looking at from a product perspective. If I wanted to look at it grouped by various other aspects, I could across the various cloud vendors. And we also have cost categories as well. So you can actually define permanent cost categories that allow you to basically capture cost by department, by development team, etc. So one-time definitions of what defines a cost and bucket stuff into another category as well. Having a quick look at how these are composed, just to sort of show you the simplistic nature of them. At the end of the day, like I mentioned, we're trying to encompass a cost here. And we do that by defining the various rules. In this example here, we're actually pulling in some containerized cost in the first section. You can see we're able to reference any labeling or tagging that you've got in place. We're able to reference the cluster names, the namespaces, all that sort of fun stuff. We're also combining costs from Azure here. We're actually pulling in various resource types, subscription IDs, AWS. I mean, pretty much this interface is as simple as, what do you want to reference? You want to make it inclusive, exclusive, shouldn't be null, like, etc. And then all the values are presented for you. You can also define how you want the default view to be. So what is that initial group by experience? Are we viewing data for the last 7 days, 30 days, current month, last month? All of those are options. That's embarrassing, as always. Hold on. Let me just refresh my screen. I think actually, I haven't actually finished filling out this bottom rule. So let me get rid of that and just move to next. There we go. So once you've got a perspective, obviously you don't want to force your users into the system. So you can set up multiple schedules so that they can just get a PDF report. And then if there's something of interest or note, they can come into the system and slice and dice the data further. You can set up budgets. I'm going to talk about those in just a second in a little bit more detail, and alerting on those budgets. And then lastly, we also do anomaly detection on spend. So Bob here is also receiving alerts on anomalies. So let's go into those budgets real quick. The specific cost spend that we were looking at here, the web order platform, it has two. It's got a monthly and it's also got a quarterly. We can see here, where we're at. So it looks like for the current month, we're going to come in a little bit under. But a bit concerningly, our goal for the quarterly looks like we're actually going to be over budget based on where the forecast is going. Once again, this is all wizard-based. You can actually do growth projections in here. You can do weekly, you can do annual as well on the budget period. This one's actually set up for quarterly. I would consider this all standard, meat and potatoes of what you should expect from an enterprise-grade solution. And, for those people that are doing stuff at scale, everything I'm showing you in the UI, there's also an API for. So you can obviously programmatically create and manage some of these if you want to as well. So moving on, I mentioned alerting of anomalies. So one of the things about setting a budget is it's a known quantity. You're planning for it. You're sort of saying, hey, this particular spend, we anticipate this is how it's going to grow, and so we'll set a goal. And if it looks like we've got variation against that goal, let's get an alert, please. Well, anomalies are slightly different because it doesn't actually require you to set up any rules or a budget or anything like that. But essentially, what it's doing is it's identifying when we're seeing growth anomalies within the spend. So, for example, I've got this anomaly where a particular cost within my environment has gone up 244%. So we can sort of delve into that and see a little bit more. And you can sort of see from this graph here, we were in these sort of like 100, maybe 140 type range, and then suddenly the usage of this particular spend and product within our GCP environment has suddenly spiked, essentially. So once again, Harness is just automatically tracking this, does it for GCP, AWS, Azure, okay? And it will give us these anomalies. And then once we've got an anomaly like this, we can obviously slice and dice it a little bit further. We might be doing some labeling in the environment. So I want to view this by label so I can see more specifically where the spend is actually going. But likewise, I also have the ability, if I go to the right tab here, there we go, to actually use our dashboarding capability to drill a little deeper, okay? So obviously not everyone may be familiar with all of Google's products, but within its analytics product suite, it has a enterprise-grade dashboarding tool called Looker. So Harness has actually chosen to embed Looker as part of our product suite here, including cloud cost management. So this is an enterprise grade dashboard that we're looking at here. I can show you how we can edit dashboards, make copies of the ones that Harness provides out of the box and all that stuff. That's all available to you. So here, once again, we've actually drilled down to that specific project and that product that we had the anomaly on. And I can start seeing some more details. I can see in my top window here, okay, well, what's my spend over the last several days? And it's sort of showing me that, yes, this problem is pretty much specific and unique to North America. That's the one that seems to be where the dollars are spent. Down below, I've included a line chart so I can sort of track, yeah, this is where that anomaly was, and then it suddenly spiked, okay? Whereas my other players are down below. And once again, anyone that's actually used any of the major dashboarding products are going to be pretty familiar with this. Whether or not it's Tableau, it's Looker, etc. You've got all your visualization techniques at the top here. You've got all the data referencing. You can do your filtering, all that sort of fun stuff. So this is really part of that deep visibility that you should expect, from any sort of cloud cost management type solution. And as far as the data that's available to you, we can see here. Looker calls these explores. Think of them. You can think of them as database tables or views or whatever, depending on your experience and background. But we've got them here for AWS. We've got specific technologies within AWS. You've got your compute, you've got your storage, etc. Azure, GCE, we've got disk, we've got instance, which is the compute for GCP here. So these are all available for you. Once again, I'm just saying, we chose to include Looker because it's a great tool. And some of these explores down the bottom are actually part of our other product modules, which we can see icons for on the left. So it is a very important piece that provides visibility across our platform. So moving on, here's a more specific example from a cost perspective. So this is one of our out-of-the-box high-level GCP cost dashboards for executives. Sort of tells me, what are my major project spends. Looker does a great job of doing trending and telling you when, things are increasing in spend, decreasing, etc. We've got forecasts down the bottom where we're at. Most extensive products. And once again, these are just canned out of the box ones. You can actually make copies of these, edit them, generate your own from scratch. All very powerful stuff. A couple of things as an end user of dashboards, which are quite nice. An end user can actually set up their own alerts. They can get very specific on this. They can actually base it on the cost trends. So if I own the big query spend, and I want to know if it's going up more than 5%, I can actually create my own alert as an end user. Okay, so separate to budgets, separate to anomaly detection. You can get very detailed from an end user perspective on, hey, tell me at the end of every day or tell me on a weekly basis that a spend that I own is sort of going out of control or out of bounds. So moving on a little bit from visibility, what I'm going to talk to next is containerization and optimization. Okay, so part of our overview screen that we saw was cluster cost breakdown. So once again, this is Kubernetes, this is ECS, Elastic Container Service within AWS. And essentially, we track three major components of all the costs going into this area with this cost breakdown. The cost that you want to see more of, the purple one here, is the utilized cost. Okay, this is actually telling me, this is the real CPU memory and storage that's actually being used. Okay, so that's a good thing. You always want that cost to be high. Okay. Problematically, and what we see at a lot of customers, because they just haven't had good, real-time visibility into this, is you're going to have two other types of cost. The first one is going to be idle cost. Okay, so this is essentially where the developer has over-provisioned. they've deployed their workload, whatever it may be, and no one wants to get into trouble for making something too small and it being non-performant. So they tend to go big or go home. So idle cost is indicative of where we've actually got oversized workloads provisioned into our environments. This can also commonly happen where people don't yet have the maturity in their development orgs to actually size things appropriately as you move back from production down to development. So we come across some customers where essentially they're using the same sizing across the board. So obviously the load that you get in production is not the same load that you're going to see in development. So why would you size your workloads the same? So we're going to show you how we provide guidance at each environment level so that you can do appropriate sizing and reduce that idle cost. And then lastly, actually a large piece of this is the unallocated cost. This is essentially where the development organizations have oversized their clusters. Okay, it sort of goes back to that classic problem where the cloud hardly existed, and people had to request machines, and it was such a long, laborious process. They would always make sure that the machine they requested, because they were going to have to live with it for the year, they went big. And even when we went to virtualization and VMware, sort of same thing. It still wasn't instantaneous. People would always try and request something big so that they didn't have to go back through that process again. Well, humans, similar stuff happens in the cloud as well. So people are going to say, hey, I need a new cluster. I think it should have 8 nodes, and each node should have 8 CPUs and 32 gig of memory, and I should be sorted for the year. Well, the good thing about Kubernetes and even ECS as well is it's very easy to change these things. And so why would you size perhaps for a volume that you might reach at the end of the year, at the start of the year? Because if you do that and you went linear, you're wasting half your money. So why don't we size appropriately? Why don't we use these technologies that have auto scaling, where they'll automatically add automatically add nodes to the cluster when needed. Everything's available there. It's just the visibility and understanding that people are sort of giving money to the cloud vendors unnecessarily. So how do we provide this level of understanding? So the first thing we do for clusters within Kubernetes and ECS is we give them an efficiency score. By the way, these are red and orange because they are not good efficiency scores. Efficiency is based on a scale of 0 to 100, 100 being optimal. 100 does not actually mean that you're fully utilizing your resources, because if I've got a service out there, it needs to have some room to grow during the day. Maybe it is busier in the morning and at lunchtime. Maybe you're accounting for busy weekends. So you've always got to build in some growth model. So we do that from an efficiency score perspective. Our score, to score 100, you need to be 65% utilizing CPU and memory. We allow a buffer of 30% for those peaks and troughs in actual usage patterns, and then 5% unallocated. But we can see we've got some very low efficiency scores here. Okay. Now we provide reporting on this, obviously within a perspective that we're looking at here. I could filter this down so that you can give a perspective to whoever owns specific pieces of your containerized world. Also available via dashboards. You can set all the alerting on this. So getting the message out that people have inefficient workloads and clusters is not the issue. Okay. What they really need is some help and understanding. And okay, you've told me I've got a problem. How can I resolve it, right? And so Harness does these recommendations. I'm going to briefly cover 2 in this talk track. The first one is where my node pool, okay, which is how many nodes have I actually given to my cluster. Essentially, just in case people are not fully conversant with this, a node is a VM. It's a compute instance in the cloud, okay? So I'm looking at a cluster here that has this default pool, and right now in the current column, it's telling me I've got 6, VMs. They're E2 standard 8, and I can see that each of them has 8 CPUs and 32 gig of memory, and it tells me how much they're costing me per hour times 6, obviously. okay? And it gives me what my potential monthly cost is. Now, we'll give some recommendations on the right based on the real world usage that we're seeing within this cluster, okay? Just briefly jumping over to the right here, I can see what those are. So we're actually looking at the last 7 days of usage on this cluster, and we're telling the user, hey, guess what? You've never actually consumed more than 5.5 CPUs. Remember, we've got 6 times 8 CPUs that we're paying for here, right? And we've consumed, let's just call it 34 gig of RAM. Once again, what are we actually paying for? 6 times 32, okay? So a lot of room to improve here. And we can see that in some of these savings. So Harness is actually going to potentially recommend a change in instance family, a reconfiguration of CPU and memory, perhaps having those ratios different. And so that's what we're seeing here. And we'll also say, hey, look, if you want to leave it on demand, you could save, $1,300. If this is a very low environment and you want to run it on spot, you can actually save even more. Now, you can, a lot of people, especially developers, if you're coming at them from like a FinOps approach, they're going to say, where are the facts? Where are the details? Why would I believe this tool? There's risk inherent in this, right? And so, we do allow you to play with these numbers. Okay, so what I'm doing on the right-hand side here is I'm just bumping this buffer up, and I'm saying, okay, Harness, I didn't quite believe you. I want a 50% buffer on this maximum CPU and RAM that you recorded over the last 7 days, and that will potentially rejig the configuration on the right. Or I might say, 7 days wasn't a large enough analysis window. I want you to take into account the last 30 days. Okay, and actually by doing that, we can see that CPU that was required, jumped up quite substantially. Okay, so, but they have the tools, okay, and here we're actually saying, okay, based on this peak that we're seeing here, this recommendation now actually is not going to save me money. Okay, so it could be that this cluster is optimized now that we've expanded the window, and maybe we have to account for a peak period. Okay, all of this is actually based on real world data, which we collect. Okay. Coming back to recommendations, I'm now actually going to go and show a second type of recommendation. And this is a workload resizing, okay? So a lot of the times when developers are pushing out containerized applications and services, they're actually going to do a best guess on how much CPU and memory should be reserved and allocated to them. Once again, this is what you're paying for. And so if we analyze the actual usage of what's really being used, and once again, we're doing the last 7 days here, I could increase this to the last 30 days. Essentially, we come up with a recommendation. So we're actually saying, hey, you don't need a whole CPU here. In fact, you need a fraction of a CPU. This would actually be 1/100th of a CPU that we're looking at here. And you don't need 4 gig of memory in this environment. You only need 32 meg. Okay. So similar concept, you can say, well, I need to take into account quality of service here. I think these numbers, I'm going to put in some leeway here. That's all available to the user. Everything that we're looking at from recommendations here. So I've sort of shown you, hey, we've got the visibility. We're going to tell people, hey, there's a problem. Here's where the inefficiency is. You can report an alert on that to the users. You've got the deep visibility in how they can take corrective action. And you can automate this sort of further. We've also got APIs available. So we have a major medical device company that's currently in the process of actually using, they've got such a sort of such a widespread problem that they didn't even want to use the UI for this. So we do have the API fully available. So they're actually getting all the recommendations for a cluster out the API, and they're resizing workloads en masse. And they're looking to save several $1 million this year. Okay, let's talk. Oh, and sorry, here's just an example of another dashboard that's looking at that efficiency. Because one of the things about, when Harness engages with customers, you obviously need to be able to track, well, how am I improving? A great way of doing that is obviously with dashboards, because you can sort of track, what's my efficiency score over time? How are my costs breaking down? Forecasted, where do we think my costs are going? Everything's available in dashboards. So it's a great place to record KPIs on, am I improving or not? So next I'm going to move on to automation. And this is full-blown automation, saving money. Okay, so we've done visibility, we've done recommendations. Now let's talk about stuff that can, you can set up and sort of forget about it, and it's just going to start saving you money. So auto stopping is the concept of, one, why are you paying for resources when they're not being used? Okay, so if you ask that question, then you say, okay, well, when they're being used. So what you need is you need the capability to understand when is a resource actually not being used. Okay, so that's one of the things that Harness auto stopping provides for you. We are able to determine, is a website, is a service that you've got deployed actively being used or not? If it's not, we can automate the shutdown of it. We can actually shut down additional components that are associated with it, like RDS databases, mid-tiers, and classic 3-tier, all that sort of stuff. And then obviously the real trick is, well, if we can detect when there is no activity, we can also detect when activity comes back, okay, and then automatically spin those resources back up. So that's the sort of game changer that we're doing here. Traditionally, companies have tried this, with schedules, and the problem with the schedule is, it's hard and fast. End users don't really like them. In fact, a major online retailer that actually tried doing auto stopping with schedules, and their business units pushed back and they abandoned the project. Okay, and they're one of our biggest users now. So let me show you why. So I've got an application here that's actually got a couple of servers in it. This is the web interface, and we can see it's currently in a stop state. So I can actually introduce activity to this. So I'm simulating a user now wanting to hit this website and the application that it services. And so Harness detects that, and it says, oh, okay, the resources are currently stopped. Let's spin them back up. So this would be an example of, people coming in, having gone home for the night. We've quiesced the resources. They come back in the morning, and someone clicks, and the resources automatically start and spin back up. A lot of organizations actually have machines that you may be able to stop during the day. Like a QA environment that is maybe only gets utilized 4 hours a day. At various points, someone kicks off a QA test, and then there's a 1 hour or 2 hour gap before the next test comes in. Why not shut the machine down? The cloud gives you that capability. You just need to automate it to actually get the savings. So let's go ahead and have a quick look at what the rule definition is behind here. Okay, so I'm operating in a demo environment, so I have a very short idle timeline. Okay, realistically, people put in things like 30 minutes, maybe even an hour. Okay, it's not normally as short as 5 minutes. You can actually do this. So I'm operating in an AWS environment, so obviously talking EC2. Everything I'm showing you also applies to Azure VMs, as well as the Google GCE compute as well. We handle auto scaling groups. Once again, everything I'm talking about, you can do to Kubernetes services and deployments, as well as ECS from a containerization perspective. And we've dipped our toe into cloud native offerings such as RDS from AWS. So we're going to be actually including some more of those, essentially cloud services that do allow you to actually stop them. And obviously, we're going to be including more where you're actually going to garner savings once again, if it's not being used, why are you paying for it to be up? As long as the technology allows you to stop it. An additional benefit what Harness can do on the compute side, you can actually have us manage running instances on Spot. Okay, so once again, just I'll spell it out. Maybe a lot of people on the call already know. On demand is the most expensive form of compute you can buy. You can get into the reserved instances and the saving plans, and that's going to get you about 50% savings, depending on who you are, your size, etc. Spot instances, if spot capacity is available, that actually gets you to the 80 to 90% savings. So the fact that Harness can actually say, hey, if I bring out this instance from a stop state, like an idle state, do you want me to manage it on Spot first? And if Spot's not available, I will bring it up on demand. Okay. But Harness can do that for you. One of the things to note about Spot, if there are technical people on the call, Spot instances can go away. Like the cloud vendor can actually send a notification saying, hey, I've got no Spot capacity left. Everyone's paying top dollar. I'm going to terminate this instance. Harness will get that message from the cloud vendor, and it will automatically move the instance over to on demand, so you've got continuity. Okay. So that's everything that Harness is doing from a Spot instance, allowing you to garner that up to 80 to 90% savings on compute. We handle things like dependencies. So I mentioned this is the UI rule, but it's actually referring to a mid-tier machine as well as an RDS backend database. So if no one's hitting the web server front end anymore, I'm actually going to shut down 3 servers as part of this configuration. We can still do fixed schedules. Like I said, this is a capability that people tried first. Sometimes they scripted it, and it just usually does not have a good user experience, and people are forced to turn it off. But there are times and places where you want to do fixed schedules. You might say, hey, listen, I just know from 8 a.m. to 6 p.m., I always want this up. Don't auto stop it. Maybe people go to lunch, but I don't want them to have the experience when they come back from lunch that it takes 5 minutes to spin everything back up. Just keep it on during working hours. Then you can auto stop it outside of those hours. Or another use case is, hey, you can auto stop anytime, but these servers have a patching window on Tuesday. So from Tuesday from 10 at night to 2 in the morning, I want to put in an uptime schedule where even if it is idle and it's stopped, you need to spin it back up so that I can patch those servers. And then lastly, what is idle? So I've talked about idle resources, right? So we can determine idleness via several methodologies here. We can do it, let's say, via any form of network traffic. In this example, it's just HTTP. We can also do it via other access protocols. So, for example, this might be a server that someone's logging into. Could be a jump host, something like that. So if we determine that we're actually seeing user activity via SSH, RDP, other protocols, we've got a customer that does TLS, a lot of Microsoft SQL Server backend stuff. So we can handle all those types of monitoring to determine, hey, is this machine actually idle? Is it being used? We've got that covered. We also can deploy a small agent on Linux servers to look for the presence of jobs. So, we've had the occurrence where some customers have servers that, they're idle a lot of the time, but when they're not idle, it's not that people are logged into them doing things, but jobs have been submitted. So we've got a small agent and it can check to see, hey, these jobs are still running on the machine. So the machine is most definitely not idle, it's still busy. And then when those jobs complete and are no longer present, we can sort of determine, the machine is now idle and it becomes a candidate to auto stop. So that's sort of about it from a demo perspective, and hopefully everyone's still awake. And I do want to leave a 10-minute buffer here for questions. So thank you for your time and watching.
Thank you, Robin. So we don't have any questions posted in the questions section, so we'll give everybody a minute or two to post something in there if you'd like, and we can answer those. But I don't, Terry, correct me if I'm wrong, but the observers can't actually speak to us directly, right?
That's correct on this platform. So if you have a question, you should see a little question mark over there. You can enter them in there. We'll try to answer those. Give everybody a couple minutes, and we give everybody a couple minutes back. So
Tell some dad jokes or something in the meantime. All right.
All right.
Okay. Cool. Should we wrap it up here, Terry?
Yeah, I think we'll wrap it up. Thank you, everybody, for attending. We appreciate you taking the time to listen to us. If you have any questions, we're always glad to answer them later. So contact us, and we'll be glad to answer any questions we can around, whether it's product, service, or just even how maybe to approach some of these. We're glad to have a conversation with you. Adam, Robin, you want to add anything else?
No, that's perfect. Thank you, Terry. Thank you, everyone, for their time.
All right. Thanks, everyone. Have a great day.
Thanks, everyone.